In this video, you will learn everything you need to know to get started with using Docker Compose. We'll go over what it is exactly, what problems Docker Compose was designed to solve, its common use cases, and of course, we will do some hands-on demos to learn actually using Docker Compose in practice. I am super excited to teach you all this, so let's jump into it. Now, in order to understand Docker Compose, you need to first understand Docker and have some basic experience with it. If you don't, I recommend you pause and watch my Docker crash course first and then continue with this one. Because Docker Compose is essentially a tool that is supposed to manage and work with Docker containers. So you need to understand that part first so that you understand the context for learning Docker Compose. So in the Docker video, I break down what the containers are, what images are, what problems Docker solves, and what use case it has, Dockerizing your application with Dockerfile, and all the concepts you need to understand Docker itself. So based on that knowledge, we can now understand why Docker Compose was created along with Docker and when we want to use it. Now, applications are composed of many different parts. You can have APIs, databases, any services your application depends on, and even within the application, you may have a microservices application, which is basically an application broken down into multiple micro applications or microservices. And when you're creating containerized applications, all of these different application components must be deployed and run together because they have dependencies on each other. So basically, you have a set of containers which are running different services and applications within them that need to run together, that need to talk to each other, and so on. So Docker Compose is basically a tool that allows you to define and run multiple services and applications that belong together in one environment. So simply put, if you want to deploy multiple Docker containers where each container may have its different configuration options, you can use Docker Compose to do this, to manage these containers way more easily. Now, this is just a general definition to give you some idea of what Docker Compose is, but of course, we want to understand this with specific examples and specific demonstration so that you really understand these concepts and the actual use cases of using Docker Compose, and not just a general abstract explanation of what it is. And because of that, we're going to jump right into that demo where I'm going to explain the concepts, the use cases using those demonstrations. So let's get started. As a first step, we're going to start two services as Docker containers using just the Docker commands. So we're not going to use Docker Compose as a first step so we can see and compare the before-after states. First, we're going to create a Docker network where these two containers will run and talk to each other using just the container name. And then we're going to start two containers. One is going to be a MongoDB container, and another one is going to be a Mongo Express container, which is basically a UI for the MongoDB database. Very simple use case. And we're going to run both containers using Docker run commands. So that's our first very simple demonstration. Let's go ahead and do that. So I'm going to switch to a terminal because we're going to execute those Docker run commands on the terminal. And you probably see this is a fancy, fun-looking terminal that I have been using since recently. And this is an application or a terminal app called Warp, which is actually a sponsor of this video. I actually played around with Warp and loved using it. It's free, it's easy to install on your computer. So I will be using Warp throughout the entire demo because it also helps highlight some of the commands and stuff better. So it's going to be easier for you guys to follow what I'm showing you. However, if you want to install Warp yourself on your computer, you can go ahead and check out the link to get started in the video description, where I'm going to provide all the relevant links for this crash course, including the Warp installation. So to run our Docker containers, of course, we need to have Docker installed and running. So I'm going to start up Docker and then we can start the containers. So the Docker service is up and running. Let's go ahead and create the Docker network first. So I'm going to do Docker network. And since we're going to run MongoDB and Mongo Express containers, we can call this network Mongo network. And let's create. And now if I do Docker network ls, so basically list all the networks available. These are the default ones basically that you get out of the box when you install Docker. And this is the Mongo network that we just created. Awesome. So the network is there. Now let's run our 2 containers. And if you know Docker, if you followed my Docker crash course, basically you know all this stuff. Docker run, and we're going to execute this in the background. And we have the Mongo and Mongo Express image documentation, so we can actually reference this. So first I'm going to define the port. MongoDB's default port is 27,017. So we're going to map that to the same port. So we're going to bind that to the same port on the host. Then we're going to define those 2 environment variables to basically set the admin or the root user and password. So we're going to copy those and we're going to call this admin. And this is some password. We're going to set this to super secret. So all this should actually be a refresher from Docker. We also want to specify that it should run in this Mongo network. So we're going to do network, run this one. We're also going to name our container instead of having Docker just create a random container name. So we're going to call this MongoDB. And finally, we need to specify the image, right? And this is the name of the image. And that's basically our Docker command. So I'm going to execute. And this will fetch or pull the latest Mongo image from Docker Hub repository and run it in a detached mode. Perfect. So we should have our MongoDB container running. And now let's start Mongo Express container. And I can actually bring up my previous command and we're going to adjust it for the Mongo Express. Right here, we see that Mongo Express is running on port 8080. So that's what we're going to set here. There you go. We also have different environment variables. So basically, Mongo Express is just a UI for MongoDB. And in order for us to use it, it needs to connect and authenticate with MongoDB. So we need to provide it the credentials as well that we set for MongoDB database. And we're passing those also as environment variables. But in this case, the environment variables are named differently. So that's what we're using, referring to the official documentation, which you always should do to get the most up-to-date data. And you also see the default values for those environment variables. The port is correct because that's what we binded it to on our host. And MongoDB server, which is going to be the MongoDB container name. In our case, it's different because we called our container MongoDB. So we're going to set this environment variable as well. So right here, I'm going to add this and we're going to set this to MongoDB. Let's not forget the backwards slash here. So the ports are correct. The environment variables are correct. We're going to run it also in the Mongo network. We're going to name this Mongo Express. So that's going to be the name of the container. And let's see what the actual name of the image is. I'm just going to copy that so that I don't make spelling mistake. And that's it. Let's execute this as well. And seems like it started without any problems. Let's see. Perfect. It's running. And now to test that it was actually able to connect without any issues to the MongoDB database container, we're going to access it in our browser. So we opened it on port 8081 on our host. And it is asking for basic authentication in the browser. And we can actually get those in the logs. Let's do that. Docker logs of Mongo Express. And here we have the credentials. So admin pass should work. And there you go. So that's a test and a proof that it was able to connect to our database since we didn't have any connection errors here and we're able to access the application here. So this was basically just to demonstrate how you would start containers that belong to each other. So Mongo Express container actually depends on MongoDB because we don't need it without the database in the background. So kind of start containers that belong together, that should run together using just plain Docker, and also starting them in the same network so they can talk to each other in that isolated virtual network. Now, obviously, these are just 2 containers, but if we have microservice application with 10 different services that has a messaging service, maybe 2 databases that it belongs to, maybe those databases have their own UI services that we want to run in addition. So now these are lots of containers that we need to start and manage using just plain Docker commands. And now imagine if you need to stop those containers because you don't want to have them running all the time, or you want to make changes and restart them again. This is going to be a lot of manual, tedious work, and you don't want to execute these commands all the time on the command line terminal, especially when you have tens of containers. So you want an easier way to manage, to stop, start, configure containers that you want to start together. And that's exactly where Docker Compose comes into the picture. So Docker Compose basically makes running multiple Docker containers with all this configuration that we just defined on those containers. So you have the environment variables, you have ports, maybe you have multiple ports on the same container, same application that you want to open. Maybe you want to configure additional volumes, for example, for data persistence. So that's the main use case of Docker Compose. So with Docker Compose, basically you have a file, a YAML file, where you define all this configuration, a list of containers or services that you want to start together, and all their configuration in one central place in a file that you can modify, configure, and use to start and stop those containers. So let's see how the file looks like and how these Docker run commands actually map to the Docker Compose. So how can we migrate or map all of these and write a Docker Compose file that starts those 2 containers with exactly the same configuration that we defined here. So this is a Docker run command of the MongoDB that we executed previously. So basically with Docker Compose file, what we can do is we take the whole command with its configuration and map it into a file. So we have that command defined in a structured way. So if you have, let's say, 10, 20 Docker containers that you want to run for your application, and they all need to talk to each other and interact with each other, you can basically write all the run commands for each container in a structured way in Docker Compose and define the entire configuration there. And this is how the structure in Docker Compose will actually look like. So the first 2 lines are required attributes of Docker Compose file. With the first line, we basically define the version of Docker Compose, which is the latest version that should be compatible with the Docker Compose that you have installed locally. So the latest Docker Compose tool installed on your computer will be able to read the latest Docker Compose file version. And then we have the services. And Docker Compose is super simple. Services is basically an attribute where you can list all the services or all the containers that you want to run as part of this Docker Compose file. So in this case, the first service we want to define is MongoDB, and that maps actually to the container name. Or rather, this is going to be part of the container name when the services are created as Docker containers. And for each service, like MongoDB, we have all the configuration for that specific container. So the first one is obviously image, because we're building the container from the image. So we need to know which image that container is going to be built from. And of course, you can specify a version tag here next to the name. The next one is the list of ports, because you can open multiple ports on a container if there are multiple processes running inside the container, but mostly you would just have one. So this is where we define the port mappings. So mapping a container port to the host. So just like in Docker command, the first port refers to the host, the second one refers to the port inside container. Then we have the environment variables listed under an environment attribute like this. And this is actually how the structure of Docker Compose looks like for one specific command. Now let's actually add the second container command for Mongo Express and how that maps into our Docker Compose file. So again, we have the service, which we can call Mongo Express. And by the way, the service names are completely up to you. You can call them whatever you want. Just like the container names, you can call the containers whatever you want. And under that Mongo Express, we have the same exact configuration options. We have the image, which refers to Mongo Express image. Again, you can have a tag here if you want to have a specific one. Then we have the port and all the environment variables that we defined with Docker run command under the environment attribute. And this is how Docker Compose will look like with multiple services defined inside. So basically, Docker Compose is just a structured way to contain very normal, common Docker commands. And of course, it's going to be easier for you to edit this file if you want to change some variables, or if you want to change the ports, or if you want to add more services with those services. And as part of everything as code trend, Docker Compose is basically a code that defines how your services should run within a file that you could check in to a code repository and multiple people can work on it together, compared to a command that you just execute manually on your computer with individual Docker run commands. The final thing here, which you may already noticed, is the network configuration is not defined in the Docker Compose. So we didn't map that part from the Docker run commands. So this Mongo network that we created, we don't have to explicitly create or define it in Docker Compose, because Docker Compose will actually take care of creating a shared network for all the containers from the services list that it's going to run when we execute this file. So we don't have to create the network specifically and then specify that all the containers run in that network. Docker Compose will automatically take care of it. And we're actually going to see that in action right away. So now let's actually go and create a Docker Compose file in a code editor. So in this projects directory, so basically where I'm in the terminal, I created this mongoservices.yaml file, which is my Docker Compose file with those two services defined here. So exactly the same code that you just saw. We have our credentials, all our environment variables defined. And since this is a YAML format, please make sure that your indentations are correct, because YAML is a very simple language, but it's very strict on indentation. So the services need to be on the same level, and then inside that service, you need to have correct indentation for the configuration attributes. So now, compared to the Docker commands, it's going to be easier for me to go here to this file. First of all, see what services I'm running with what configuration, edit those, make any changes, add any new services that I want to run. And now let's actually execute this Docker Compose file and see how it works. Back to my warp terminal, I'm actually going to stop all the containers because we want to start them using Docker Compose. So that's the first one. Let's stop them. We can actually remove them. And we can also remove the Docker network. And there you go. So we have a clean state, no containers running. And now how do we execute a Docker Compose file with Docker Compose? Good news is if you have Docker installed on your computer, that means you automatically also have Docker Compose installed. So you don't have to do that separately. That means we should have Docker Compose command already available as part of Docker. And Docker Compose takes one attribute, which is the file name, Mongo services. There you go. And the command, which is up, which basically means go through the Docker Compose file provided here and start all the services configured right here. So let's execute this and we're going to see the result. Awesome. So now there are a couple of interesting things that I want to point out and highlight in the output that we got, and also explain some of the interesting concepts behind. So let's go through them one by one. I'm going to scroll all the way up to the beginning of the output, which is right here when we executed Docker Compose command. The first one is, I mentioned that Docker Compose takes care of creating a dedicated network for all the containers. And here we see in the output that it actually created a network called projects_default. So this is the name of the network, and it's going to run those two containers in that network. So if I open another terminal and if I do docker network ls, we're going to see projects default network was created. Another interesting thing to point out is the container names for those two containers. So in the Docker Compose, we actually called those services MongoDB and MongoExpress. However, as you see, Docker Compose actually added a prefix, projects, and a suffix at the end to each service. So this is basically the folder that contains the Docker Compose file, where the Docker Compose file is located, as you see right here. So Docker Compose always takes the name of the folder where the Docker Compose file is executed, and it uses it as a prefix of the container. And then you have 1 as a suffix. So we have 1 instance of each container. And that's how the containers are called. And we can also check our containers. And here you see the names. Projects MongoDB 1. Another interesting thing to point out is that you see that the logs of those 2 containers are actually mixed. So we have the MongoDB logs, Mongo Express, then MongoDB again, and so on. Because we're starting both containers at the same time. So if you had 20 services defined here, they will all start at the same time, and you will see the logs basically just mixed together on startup. However, when you have multiple services where some services actually depend on the others, in our case, Mongo Express depends on MongoDB because it cannot establish a connection, the initial connection, with the service until MongoDB is fully up and running. So we may have such dependencies, or we may have an application, our custom web application, that also needs to connect to the database when we actually start the application to fetch some initial data and so on. However, if the database is not up and running when the application starts, the application will fail with an error because it won't be able to connect to the database because it's not ready for the connection yet. And you may have lots of such dependencies when you're running multiple services as part of one application. And this is something that you can define in Docker Compose with a depends on attribute. So you can explicitly say this service actually needs to wait for another service or container to be fully up and running until this container is created with a very simple depends on attribute. So basically we can say the Mongo Express service depends on, and we can have multiple dependencies. So for example, we can say an application depends on 2 different databases to start, plus an authentication service. So all of those should be up and running until we start the application, because otherwise it's not going to be able to connect to those on the initial startup. So depends on takes a list of the services, and it basically says, wait until all the dependent services are fully up and running before you start this service. So we can fix it very easily using this attribute. And now since we have both services up and running again, I'm going to refresh here and we should see Mongo Express accessible from the browser. And we can actually do something here. So we can change something in the database. So for example, I can create a MyDB database. And inside that, I can create my collection. I'm very bad with names and not very creative. So that's all we got. We have MyDB and my collection. And this actually creates those in the actual MongoDB database. Cool. And if I go back to the terminal, we should actually see all these change logs from Mongo Express, and in MongoDB basically logs new entries in the database that it created. Cool. Now, what do we do if we want to stop those containers? Or maybe we want to change some configuration in Docker Compose and restart those containers. Right now, since we have the Docker Compose process running in the terminal, we're going to need to do Control-C to basically break out of the process. And this is going to stop both of the containers. However, just like with Docker run commands, we have the detached mode. We can actually run Docker Compose in the detached mode like this. So we'll start the containers in the background. However, now if we want to stop the containers, we could stop them using Docker stop commands and providing the ID of the container. However, again, if we have 20 containers running, this is not going to be an efficient way to do it. And with Docker Compose, it's also very simple, actually. Instead of up, we do down. And what this will do, if we have 20 services defined here that are running as containers, is going to go through all of those. And it will actually not only stop those containers, but also remove them. So now if I do docker ps a, so this shows running and stopped containers. So all the containers in any state, you see that we have no containers because they have been removed completely. And you also see the network itself was removed. So basically with Docker Compose down, you have a very easy way to clean up the entire state so you don't have any leftovers of containers and networks that you created previously. Everything will be completely removed. However, when you're running containers and when you make changes like we did in the database for testing, you may want to retain those changes, the state or the data in those containers. So you don't want to completely remove the containers, you just want to stop them and then restart them. And as you've learned in the Docker crash course, containers are ephemeral, they have no persistence, so all the data is gone when you remove the container, because by default it doesn't have any persistence, unless you configure that persistence with volumes. However, if you just stop the containers and restart them, you will still have the state and data because the container itself was not removed, it actually stayed locally. So to demonstrate that, let's do up again. And with Docker Compose, you can execute a stop command, which simply stops the containers. And if I do Docker PS A, you see that the containers are still available locally. They're just not running. They're in an exited status. And we can start them again using Docker Compose start command. And if we refresh, our MyDB database and collection are gone. We can create them again like this. We can restart using Docker Compose and the data should still be there. So that's basically the difference between up and down commands compared to start and stop. And obviously both have their different use cases. And one more thing, since we are executing Docker Compose commands very often, like this one, for example, we can actually go ahead and bookmark this like this. So if we have too many commands in the history, for example, and if we are scrolling around, which basically creates this visual marker, and you can just click inside and it jumps directly to that command. We can then copy that command and execute here. Perfect. So now before we move on to the next part of this demo, where we connect our own custom application to the MongoDB database and run it also as part of Docker Compose service, let's go to the database, and in our new collection, let's actually create a new document that our application is going to need. It's going to be a very simple document. Let's add 2 more attributes here. So we're going to have, let's call this my ID again. As you see, I'm very uncreative with names. So this is going to be an ID that we can reference in addition to this generated ID. And then we're going to have the actual data, which is going to be a string. And we're just going to write here some dynamic data loaded from DB. So when we load this from our application, we know that it's coming from the database. So I'm going to save this document in the collection. You see it was created here. Here are the values, the generated ID, my ID, literally my ID, and this data text. Okay. And we're going to make this a little bit more interesting. So we're going to use a custom JavaScript application, which is a super simple application with just one file that simply connects to the MongoDB database and displays the data in the browser. So we can see some of the concepts in action. And we're going to containerize our JavaScript application and run it as part of the Docker Compose services. And of course, I'm going to provide the link to the Git repository where this JavaScript application is hosted in the video description. So you can just clone it locally to follow along. And by the way, you will also find the Docker Compose file in that repository. So all the code that we write in this demo will be there. So I have cloned my own application locally in the projects. I've called it Docker Compose Crash Course. So let's switch inside. And to show you how simple the application is, I have opened it in the Visual Studio Code. So I don't have the Docker Compose here yet. This is the entire application. We basically have the server.js, which is a Node.js backend, and index.html, which has the style, the JavaScript code, which is basically just one function, and the HTML code in one file. So the simplest app ever created. So first of all, you don't need to understand any part of this code. We're just gonna concentrate on the configuration and the Dockerization part of this app. So even if it's simple app, you don't need to understand the code, but just to run through the logic on a high level, this backend basically connects to the database logic. We have this index.html file, which shows 2 lines of data. We have some static data, which is hard-coded in the file itself. And then we have data that is supposed to come from a database. So this is empty. So we're going to set it dynamically from the data that we get from the database, which is going to be this data right here. And the way we do that is in this JavaScript section, when we load this index.html page, it basically, the front end basically sends a request to our server.js backend, and it says, fetch the data. And in server.js, we accept that request right here. We connect to the database using this logic right here. And note that we are using MyDB and MyCollection as the database and collection name. That's why we created them in the database. And it connects to this collection, and it basically grabs the element that has this key value pair inside, myID1. So it's gonna get this data here from the collection, and it's gonna send that, the whole object, back to the front end as a response. And then we're gonna grab the data attribute from that response. That's the data. This is the value of the data, and we're gonna set it as the value for this second line. So that's how the whole thing is gonna work. And in order to connect to the database, because remember, we actually set username and password on MongoDB, so our application needs to have that same username and password, just like the Mongo Express container had to have those credentials. So we are providing those also as environment variables. So just like Mongo Express had to receive those values as environment variables, our application is also going to receive those as environment variables with these names. So MongoDB username, MongoDB password. And we use those to connect to the database. That's the entire logic. So now our goal is to take this application to build a Docker container out of it using the Dockerfile blueprint, which is right here. Also very simple, because it's a Node.js application. We use Node as a base image. We basically take the code that we have here in the app folder, we copy it into the image, we run npm install to download the dependencies inside the image, and then we just start the application using node command, which comes from here, and server.js file, which is this file right here. So it starts the application on port 3000 and logs this as a first log of the application. So we want to use Dockerfile, and again, you learn Dockerfile in the Docker crash course, how to use it. So all this should be familiar to you. So we want to build our custom JavaScript application as a container and run it as part of Docker Compose along with MongoDB and Mongo Express services. That's the goal. How do we do that? First of all, we need to copy that Docker Compose that we created into this application code. And remember, another interesting point to highlight here, Docker Compose is part of the application code. So developers work on Docker Compose just like they work on Dockerfile and other parts of the application code, which is the best practice to have all this logic together in one repository instead of scripts and commands spread on laptops and computers of different developers. Everything is in a central place. So we created this Docker Compose file in the projects folder, and we want to copy this into this folder. So let's do a simple copy. There you go. And here we have our Mongo services.yaml Docker Compose file. And as I said, we want to add our application as a third service, which is going to run as a container service. But we don't have the image yet, so we need to build the image as well. In Docker Compose, what you can actually do, you can define both in one configuration. So we can build and then start the container with Docker Compose. So right here, I'm going to add the service for our Node.js application. And let's call this my app, because great with names. And instead of image, because we want to build that image first, we're going to simply provide build attribute and the build context, which is current directory. And this basically points to where the Docker file is located, as well as the entire build context for that image. And the rest of the configuration is going to be the same as for other services. So we have the ports. In our case, we're starting this application on port 3000. So that's what we're going to define right here. So port 3000 inside the container, we're going to bind it on 3000 on our host. And as we saw, we have the environment variables defined here as well. So we need to set those so that our application will be able to connect to the database using those credentials. And that's basically the entire configuration. This will build our Node.js application image using Dockerfile as a blueprint for the image. And it will start it as a container on this port and pass in those environment variables that our application will read here and use it to connect to the database. Now, we don't have to configure depends on here because the application doesn't actually connect to the database when it starts up. So this is the startup logic. So here we don't have any connection. It only connects to the database when we load the application in the front end in the browser. This function gets executed, or this script gets executed. And because of that, we don't need to do depends on here. And now let's go back to the terminal. Let's first of all see whether we have containers running. Let's get our command to stop those containers. So we're not going to remove them because we need the database collection and the data inside for our application. And now I'm going to go into the Docker Compose crash course folder where we have the new Docker Compose. And I'm going to execute Docker Compose up, and let's execute. And as you see, it is actually building the new Docker image from the node base image. And that was actually pretty fast. And now we should have all three containers running. Let's check that. And we have really bad names for our containers because the name of the folder is very descriptive large name, which was used as a prefix for containers, but that's fine. And these were created from scratch. So our previous containers with this prefix are not actually running. Instead, it created new ones. And that brings me to another concept, which is you can actually override the value that is used as a prefix. So maybe you want to reuse the same containers, but you have moved the Docker Compose file to another location. So let's actually remove those containers that we just started, like this. So now we only have those two. And the way we can override is using a flag on Docker Compose. So we can add an additional flag here, -p, or also project name. So essentially the name of the folder is assumed to be the project name. So we can override that project name value using this flag. And we can call this projects, which was the previous one, like this. And let's start the container. Let's do Docker PS. As you see, our old instances of MongoDB and MongoExpress were restarted instead of new ones being created, plus the network called projects default that was already there. And that means if I refresh this, we still have our MyDB and my collection and the data inside for our application. Which means if I visit the application on localhost 3000, we should see our awesome application. And let me refresh this once again so we can see the network traffic here. We refresh. So this was the fetch data request, which we execute right here, that basically returns this object that we created here from in the database back to the front end. So if we go to preview or response, we see this object with my ID 1. This is the ID from the database, and the data, some dynamic data loaded from DB. And we're using that to set this line right here. So if I actually went there and changed this, like this, and let's save, I'm going to refresh again. You see that now we get this updated data from the database. So the entire connection works. Our application is connected to the database and displays that information right here. Now, I mentioned that Docker Compose is part of the application code, which means it gets committed and stored in a Git repository so that everyone can work on it. It's available for the entire team. If a new engineer joins the team, they download the code, they have Docker Compose, so they know exactly what services are running as part of that application, and they can easily start that locally. However, that also means that it's really bad that we are hard coding our secret credentials in the Docker Compose file, because the best practice for security is that you shouldn't hard code any sensitive data in the application code so it doesn't end up in the Git repository. And even if you remove it later, if you accidentally checked it in and removed it, it's still going to be in the commit history. So you shouldn't have any hard-coded values here. So how do we solve this? Because we need those credentials to be passed on to services. Well, for that, we can actually use variables or placeholders in Docker Compose instead of the actual values. And we can set the values of those variables as environment variables on the operating system. So let's see how it works. First of all, we're going to remove all those hard-coded values, and instead we're going to define the variables in Docker Compose, which has a syntax of $ and then curly braces. And inside that, we can name the variable whatever we want. I'm going to call this Mongo admin user because it's the admin user in MongoDB. And by the way, this could be lowercase. You can call this really what you want, but I'm using a standard environment variable name convention here with all uppercases. So we have the admin user. Let's call this admin pass for password. And we're going to reuse those everywhere. Which is another advantage of using variables, because if you change those values, like if you change the password value, for example, you just have to change it or set it once and it automatically gets updated everywhere. So now this Docker Compose does not have any hard-coded sensitive data, and it's safe to check it in the Git repository. However, we still need to set those actual values. So to test that, let's go back to the terminal. First of all, I'm going to stop those. Stop the containers so we can test that everything works. And on the first Docker Compose command execution, we get a warning that says the variables are not set. The containers were stopped. However, we need to set those as variables in our terminal session. So we set them here. Export Mongo admin user. Let's set the other one. Like this. And the same way as we did with the up command, we actually need to specify which containers we're stopping. So by default, it's going to look for containers that start with this name, the name of the folder. So we need to override that projects tag again. And there you go. And I'm actually going to bookmark this one as well. Like this. And if we refresh, we should see that the pages are not working because the containers are stopped. And then let's start them again. And if we start them again with those environment variables set, everything should work same as before. Let's wait. There you go. Now, I want to mention here that Docker Compose actually has a concept of secrets, which is another functionality to manage the secrets, especially when you're running Docker Compose in a production environment, which is exactly for this use case where you need to pass in credentials or any sensitive data to the services defined in Docker Compose. So you can use Docker Compose secrets as an alternative to this method, basically. Awesome. We have just learned the fundamentals of Docker Compose, and more importantly, you understand its core use case. And by the way, I want to highlight the importance of learning tools like Docker and Docker Compose, or generally cloud and DevOps technologies, because nowadays it is becoming more and more needed for software developers to learn those tools to become more valuable in their roles, especially in the current tense job market where we have layoffs and companies hiring less. As more and more companies are adopting DevOps, it is a great way to stand out among developers who only focus on programming and are not interested to learn new concepts and tools that are being adopted in the industry. So I think it's definitely more important than ever to educate yourself, keep learning, and with DevOps or cloud engineering skills, you will definitely be ahead of 90% of developers. In fact, most of our DevOps Bootcamp students are actually software developers or software engineers, since many companies do not have a separate DevOps engineer role, but often their responsibility lies on senior developers to set up the DevOps processes like release pipelines, for example. So even if you are a junior software engineer, learning DevOps and cloud skills and technologies will absolutely accelerate your career to a senior engineer. So if you want to get a complete education on DevOps, to take over DevOps tasks at your work, then definitely check out our DevOps Bootcamp. You will learn various technologies from zero to an advanced level to be able to build real-world DevOps processes at your job. And if you need some guidance before, you can also contact us there with your questions. So check out the information below, and let's move on to the next part. So now we are building and running our JavaScript application as a container along with MongoDB service and the MongoDB UI, but usually that's a testing environment. As you learn in the Docker Crash course, eventually you want the JavaScript application, your custom application container, to be stored centrally in a Docker registry, or rather the image to be stored in Docker registry, so we can start and deploy it as a container on the end environment, on an actual deployment server where end users will access it. So we need to build the image and push that to the repository, like a Docker Hub repository or whatever other Docker repository you want. And now the interesting question is, after we push the image to private Docker repository, how do we reference our custom image from our private Docker repository in Docker Compose? And also note that when we run this on an actual deployment server, we're going to copy the Docker Compose on that server where we have Docker and Docker Compose installed. And when we run this Docker Compose file or execute this, it will go through all the services and it will pull all the images defined here and run them as containers with all this configuration. So we pull the official images from Docker Hub public repository and any custom images from the private repositories. So let's actually see how it works. It's actually very, very easy. And again, building image, pushing it to the repository, the whole thing, you should already know it from the Docker course. So this should be a refresher for you. So let's actually see that in action right here. So first of all, I'm gonna log into my Docker Hub account, and I'm actually gonna create a new private repository in Docker Hub, like this. Let's call this my app because it's generic. I may use it for some other demonstration later. So there you go. And now we're gonna build our image using the Docker file, and we're gonna push that image to this specific private repository. So let's execute those commands. I'm gonna build using Docker build command. I'm gonna tag this, and this is again a refresher from Docker course. We need to tag the image with the name of the repository so that Docker knows on push command which repository to push that image to. So that's going to be the entire name. So the image name itself includes the repository name. And we're just going to tag it with a simple 1.0. And we need to provide the build context, which is the current directory where Docker file is located. And that's basically it. Let's execute. Again, super fast. Let's list all the images so we can see what we have built locally. And there you go. This is our image with an image tag. And this is exactly the image we want to push now to the private repository. And you know, when we want to push or pull from a private repository, we need to be logged in to that repository. So we need to do Docker login. And the username is actually your Docker Hub username and Docker Hub user password. And this is actually different for other Docker repositories. So if you have a ECR or some other Docker repository, the process may be different. With Docker Hub, it's very simple. That's why I use it for the demos mostly. So we are now logged in to Docker Hub. And what I can do now is basically push that image that we just created using simple Docker push and the image full name with the tag. And there you go. And if I refresh, we should see one tag here, 1.0, for our My App image repository. Perfect. And one thing I wanted to show you here is that whenever you are building and pushing an image, you basically have the same commands all the time for the specific action. You build the image, you log in. If you're not logged in already, you push the image and so on. And I have actually used a feature called workflows in Warp for these kind of use cases, which can be really helpful if you have a set of commands that you always need for the same type of workflow. You can basically define that as one unit. So you can group those commands in one unit called a workflow, and you can save it here. And whenever you need that, you can just execute all of those commands with one click, which I've personally found super cool. So in Warp Drive, you have some options here. You create a new workflow, and I'm going to call this Docker push. And here you can list the different commands basically. So let's do Docker login, and we have the username, which was this one right here. And obviously we don't want to provide a password hard-coded here. So we're gonna pass that as a variable or argument. And we're gonna read that from the standard input. Again, this is a refresher from Docker. This is how you should use Docker login. So you don't type in the password directly. And with Warp, you can actually use arguments like this. So whenever you run this command or list of commands, before it runs, it will actually tell you, hey, you should fill out this argument. So we're gonna use an argument here. And then after Docker login, we're gonna do Docker build like we did with an image tag. We can also make this an argument. Let's make this an argument number 2. And then push that like this. You can also set default values. Let's actually do 1.0 here. And this way you don't have to type out all the commands for the same workflow. So let me check all these commands. So we need build context at the end, and the rest looks pretty good. And let's save the workflow. And the way it works is now I have the workflow right here. And whenever I need that workflow to execute, I just click on it and it fills out the terminal basically with all these commands, and it highlights the arguments that I need to set. So I'm actually gonna put my password here as an argument, and then let's say we want 1.1 as a second argument, and we can execute all the commands like this. And this will actually have pushed another tag with 1.1. So this is a cool feature that you can use on Warp to make your life a little bit more convenient. And that means now we have our image with 2 different tags in a private repository. And now if we go back to the Docker Compose, we don't need to build it locally. We can, again, this is convenient for testing, because when you're testing on a local environment as a software developer, as an engineer, you may want to just do very quick local changes in a Docker file or in application, test it quickly, and you don't want to be building and pushing and pulling image all the time. So this is a very good functionality for local testing. However, on an end environment, obviously we need to define an image that comes from a repository. Maybe we have scanned that image already and made sure that it's secure and properly configured and so on. And now we want to actually use it. And how do we reference our custom image from a private repository in Docker Compose? Very simple. Basically do it just like any other image in Docker Hub or any other repository. like this with a specific image tag that is available. Let's do 1.0. And how will Docker Compose be able to pull that image from a private repository, or basically authenticate with the private repository to pull the image? It actually uses the same Docker login that we use to do Docker push. So Docker login basically creates, after successful login authentication with the Docker Hub, it actually creates a Docker JSON file locally that creates the authentication credentials or tokens in that file. And Docker Compose in the background is using Docker to run those containers. So it's going to be the exact same process, pulling or pushing the images from Docker Compose. So that means if you have done Docker login already to that repository, then you should be able to pull any images defined in Docker Compose from that repository. That means that's the configuration. This should work now. In order to test that, let's actually stop our containers. So they're all stopped. And I'm actually going to remove the application container because we want to simulate that the container is recreated from the new image that we pull. And now if we do up again in detach mode, and as you see, my app image was pulled and the container my app was started from that. If we check the running containers, we see that this is the image that was used to create this container. Awesome. And again, we can check that our application still works. And there you go. That's how we can reference our custom image from a Docker repository in the Docker Compose. And in case when you're executing those commands, so let's say we're doing Docker build and you forget one of the arguments or use a wrong flag and so on. First of all, you get an error, but you can also do a troubleshooting feature within the terminal to actually give you a pretty good tips and notes on what the error actually is, because sometimes we make spelling mistakes, sometimes we forget an argument or whatever. So it could be helpful for a tool to actually tell you what the actual problem is so you can fix it. And Warp has this AI assistant, which is pretty cool. So for this specific error, if I open this Warp AI, which you can see on every command block. So you have this bookmark and you have this Warp AI. So if I click on this, it actually auto-generates the question because it knows that this is an error and you can ask it how to fix it. So you can modify your question or example. And if I hit enter here, it gives me an answer that the Docker build command requires an argument, which should be the path to the Docker file, and gives me an example with the correct one. So change to the directory that has Docker file and then execute this command, which has dot at the end. So I found this feature also pretty cool, which means if any of the commands give you an error while you're following this demo, you can actually use this to find out what the error is about and ideally how to fix it. So this is going to help you troubleshoot your issues. And finally, I want to actually add a few very interesting and important concepts regarding Docker Compose and kind of what the next steps are. So this final small section may be really, really interesting for you. So basically, as you see, the main use case of Docker Compose was to have a central place to manage containers that were supposed to run together, like your application and all the services that it depends on. And we configure all the environment variables or any other configuration for those services in that one file. And it also starts them in one isolated Docker network, and it makes it super easy for us to clean up all the resources. So engineers took Docker and they containerized their applications to a whole new scale that was not a standard before. And Docker was especially perfect to use as a host for microservice applications, where you have even more applications and more containers now running in one environment. And again, if you don't know about microservices, I have a separate video about them, but essentially it's when you have all the services needed to run one application, but split into separate micro applications or services. and they can be scaled independently and run independently as independent containers. So Docker was a perfect host for that. So we ended up with lots of applications, lots of microservices applications with hundreds or thousands or tens of thousands of containers. That is pretty much a standard nowadays. Such a scale actually led to Docker Compose actually not being able to handle such large scale of containers. And more importantly, engineers will have to still manually manage running and operating those containers with Docker Compose. Like if containers die or crash or have connectivity issues, etc., you have to manually detect and then debug and restart the services. Now, Docker Compose actually made some improvements on that. There are tags like restart and so on, but it's still a lot of operational effort to run the containers with this kind of scale where you have thousands of them using Docker Compose. And that's where Kubernetes kind of came into the picture to solve exactly these two main issues initially. Scaling to thousands or tens of thousands of containers. With Kubernetes, you can basically merge hundreds of servers into one huge server to deploy all the containers that belong to the same application in that environment. They will all run as if they were running on the same server. So it naturally makes it easier to scale your applications and to run thousands of instances. And the second one was the automatic operations, or making the operations of applications easier, or also called Kubernetes auto healing feature, which basically manages starting and restarting containers if they crash, and has mechanisms to manage operations of a large number of containers in an automated way when manual effort it's just impossible or not feasible anymore. And that led to Kubernetes becoming so popular. So Docker Compose is kind of like an intermediary step if you have a smaller set of containers. But with today's standards, when you want to work with very complex applications with a large scale, then Docker Compose has its limits. So that's where Kubernetes basically comes into the picture. So if you're learning these containerization and container orchestration concepts, then I would actually recommend to use this roadmap of learning the Docker, using the Docker crash course, then learning the Docker Compose with this course like you did, and then you can move on to the Kubernetes. And if you want to learn Kubernetes, I also very conveniently have a Kubernetes crash course to get you started in Kubernetes very easily. So if you want to get started with that, you can check out any of the many videos that I have on my YouTube channel, but I would recommend to start with the Kubernetes crash course. So I hope you learned a lot of new concepts. You obviously learned Docker Compose as a new tool, new technology. Thank you for watching till the end. Let me know in the comments how this video actually helped you in your work or maybe in your job application. I'm always happy to hear and read that feedback from our viewers to know that my videos are helpful in actual job environment. You can also share any other tips and learnings about Docker Compose that you have from your practical experience so that other viewers can read and benefit from it as well. And with that, thank you for watching and see you in the next video.